Okay, so our question was number 2. So you have a sample containing 3 moles of an ideal gas taken through a series of equilibrium states represented by the closed path A, B, C, D, A in the diagram. So that's this graph over here. So we kind of blew it up. So then the gas is going from A to B to C to D to A, so it's making this complete loop. So A1 asks you to rank the temperatures of the 4 labeled points from least to greatest. So the first thing we did was identify what type each one was. So A to B is isochoric because volume doesn't change. B to C is isobaric because pressure doesn't change. And then C to D is isochoric, and D to A is isobaric as well. So then when we were looking at question A, we had to rank the different temperatures. Looking at just at the ideal gas law, because we know it's an ideal gas, you have PV equals nRT. When you're going from A to B, the pressure is increasing, but the volume stays the same, so temperature must be increasing. From B to C, volume increases, but pressure remains constant, so temperature has to increase as well. C to D, volume is constant, but pressure is decreasing, so temperature is decreasing. In D to A, it's the opposite of B to C. The pressure is constant, but the volume is decreasing, so the temperature has to decrease as well. So we're going to rank those least to greatest. Then A, which is less than B, is less than D, is less than C for the temperatures at that point, because we know this is a change of 3, and this is a change of 4. So this is going to be an increase in temperature equivalent to that, or directly kind of related to that 3. This is going to be to that 4. So we know that C is the greatest, D is the second greatest, and then B is second smallest, and A is the smallest.
Okay, Martin? Okay. Okay. So, the second question is, indicated by the segment of the path A, B, C, D, A, if any, for which the work done by the gas is positive, if the work done by the gas is not positive. Okay, justify. So where is positive work being done? Well, in B, A, and C, D, it is isochoric, meaning the volume is constant, meaning no work is being done. So the only instances where work is being done is D, A, and B, C. And in D, A, there's a negative change in volume, and in B, C, there's a positive change in volume. So this is the only time where positive work is being done. So the answer is just B, C.
Okay, so for C, I have
negative volume. The volume is being decreased.
Wait, okay, it says determine the temperature TD in terms of P and V. So you just take the PV and RT, you put in the 3 moles that we were given in the beginning. It's 4 because we're moving from...
And the relationship between pressure and temperature.
Yeah, it's 4 volume, and then you just solve that out for TD. So you get 4 pressure, initial volume, initial over 3R. This is C.
So that was part A.
That was, part A,
by
part
the way.
2 that we forgot to, we skipped on. I said.
Oopsies, okay.
So C is in process AB. The energy transferred to the gas by heating, is that positive, negative, or 0? It's energy has to be positive because A to B is an isochoric, so there's no work done, and the heating is directly equivalent. Heating is equal to the change in internal energy, so pressure is going to increase in that area. We know volume is constant, so temperature has to increase, like we figured out before. So you know that the energy has to be positive because the work is equal to 0, and the temperature increases. There must have been adding heat, and so internal energy must have been added because Q is equal to change in U.
Okay. So the final one is D. Derive an expression for the net work done on a gas during the process ABCD. Express your answer in terms of P0 and the fundamental concept appropriate. So as we said before, the only times that work is being done is going to be to BC to DA because the work is 0 because the volume is the same. So considering work is the negative pressure times the change in V, we went to BC minus DA to find the net work. That will be, so BC, this is the work done, which is the change of volume times pressure, which is negative 3P times 3V, because that is the change of volume. And then minus DA's work, which would be its pressure times its change of volume to get 9VOPO plus 3O equals the net work is going to be negative 6PVBC.